My name is Nitesh. Shet. I am from Annavara. So last class we discussed about a topic from 9th standard, that is force and Newton's laws of motion. In this chapter we already discussed about what is meant by force, Newton's first law of motion and inertia, Newton's second law of motion and momentum, and also we discussed about mathematical formulation of Newton's second law of motion and based some of the problems. So let us move on to the next topic, that is Newton's third law of motion. Newton's third law of motion. Yes. So here we already know that one, that is Newton's first law of motion is relating with the force, and Newton's second law of motion is also related with the force. So the Newton's first law of motion inertia and Newton's second law of motion momentum. So that means there are some of the new terms are coming here. So here also some new terms are there here. So that one is the action and reaction. Before knowing about action and reaction, so we have to know about what is meant by force. So we already know that force is a push or pull of an object. Also we know that in 8th standard we know that one, that is force is due to interaction. That means interaction happens. So that means here in this case we want at least two objects. So there must be an interaction between two objects when the force is applied. So when the force is applicable, so when two bodies or two objects are interact each other, then only the force is experiencing. So in between those two objects the force is experiencing. That means, so one body experience or one body applying some of the forces on second body means it's action. So that means the first body experiences the first force, that is action, and the second body so applies another force. So that means that one is the reaction. That is, one is the action, another one is the reaction. But in Newton's third law of motion states that those two forces are equal in magnitude and opposite in direction. Actually, it is opposite in direction only, because here it is applying in this direction, here it is applying in this direction. But according to the Newton's third law of motion, those two forces are equal in magnitude but opposite in direction. But sometimes it depends on the momentum of an object also. But here in this case, in the standard form, so we are taking as a equal in magnitude. For example, when we throw a ball to hit the wall, then the wall also applying some amount of forces to that ball, like that. And also, so when we are standing on the floor, so that means so we are experiencing the gravitational force, but the floor is applying some of the normal reaction to against in the opposite direction of the gravitational force, like that. So that means here in this case, in the Newton's third law of motion is, for every action there is an equal and opposite reaction. So action and reaction is nothing but forces. Here for every action there is an equal and opposite reaction, means those two forces are equal in magnitude and opposite in direction. So that is, it states that for every action there is an equal and opposite reaction. Yes, equal and opposite reaction. So that means when two bodies are interacting, one body applies some amount of forces to the second body, so then the first force is equal in magnitude but opposite in direction here. So that is, so we have to write an explanation here. So this is the statement of the Newton's third law of motion. So you can write with the help of first force and second force, first body and second body, like that. So let us take that one. When the two bodies two bodies are interacting with the forces, interacting with the forces means they are applying some amount of forces are there. Okay, so interacting with the forces, the first body experiencing a force, force which is really action. This force is an action here. So first body experiencing a force to the second body, which is equal in magnitude and opposite in direction, compared to the force applied by the second body to the first body. So this means here both the objects are interacting with the forces. The first body experiencing a forces which is equal in magnitude and opposite in direction compared to the second body. So that force is equal in magnitude and opposite direction with the another force. There are two forces are there. So here I will consider first body as A and second body as B, and the first body experiencing a force, that is force applied by the object A to B, like that. So that means here when we are considering the two objects A and B, so then the force applied by the object A to B is the FAB. I will take this one as a FAB, and FB, let us take another one is the FB, that is force applied by the second body to the first body. So like that. So consider two bodies or two objects, let us say, or two bodies, no problem. Two bodies are A and B. So then what happens here? That is FAB. Then the first body experiencing the force to the second body FAB, that means force applied by the first body to the second body. I will take an arrow mark here, that is it shows vector symbol, that is the force is a vector quantity, so that's why this vector symbol or this arrow mark shows that FAB is a direction oriented, or it applying in some direction, like that. FAB and second body experiencing or second body applying a force to the first body B, FBA. So let us take this one as a FBA. I will take a vector mark here, so that is an arrow mark. So then according to Newton's third law of motion, according to Newton's third law of motion, so we can take it as a FAB, so take it in vector sign, so it is essential, it is much needed, it is arrow mark is much needed here because it is direction oriented, because those two directions are equal in magnitude but opposite in direction. Okay, equal in magnitude means both are equal. So magnitude, in case of when we are taken the magnitude means, so both are equal, FAB is equal to FBA, so both are equal. So magnitude of FAB and magnitude of FBA both are equal, but directions are opposite. So for the direction we have to insert this negative sign. So this negative sign shows that the directions are opposite. That means the direction of this force, and when you are comparing to the direction of both the forces, both are in the opposite direction. So that's why we can insert a negative sign here. So with this we can take it as a standard expression or expression for Newton's third law of motion. We can use anywhere when we are solving some of the problems based on Newton's third law of motion, or commonly Newton's laws of motion and forces. Let us take some of the examples of Newton's third law of motion here. So some of the examples are there, many examples are there. So let us take some of the many important examples. So that is, firstly I will take the fish. The fish is swimming in the water, or fish is moving in the water. So like that. So in that what happens is the fins of the fish, the small fins of the fish. So that fins pushes the water in the backward direction. So from that one, so the fish is move easily inside the water. So that's why. So there what happens is the fish pushes the water in the backward direction, means it's an action. In the opposite direction, so it is moving. So in the opposite direction, so the fish is moving, so that means the water applies some amount of forces to the fish. So that's why the fish moves in the forward direction. That is, fins pushes the water in the backward direction, the fish moves in the forward direction. That means both the forces are equal in magnitude but opposite in direction here. So first example we can take it as a fins of the fish. Fins of the fish. Fish pushes the water in the backward direction. So fish can move easily. Fish can move easily in the forward direction. That is, here the water applying some forces to the fish, in the opposite direction of the force, So this we can take the first example for Newton's third law of motion. So second, we can take second example, that is the wings of the birds. The wings of the bird pushes the air in the downward direction, so the bird can easily fly. So that means the surrounding air, pushes the bird in the upward direction. When the wings of the bird pushes the air in the downward direction. The surrounding air pushes the bird in the upward direction. So that's why here it is action and reaction takes place. Both the action and reactions are equal in magnitude and opposite in direction. So that is the wings of the bird. The wings of the bird. Wings of the bird pushes the air in the downward direction and surrounding air pushes the bird in the upward direction. Upward direction. So based on this example, there are many examples are there. So here I am taking one of the example, that is launching of rocket. In launching of rocket, so the exhaust gases or ejection of gases, hot gases, it applies some amount of forces to the ground so that the rocket can exceed, the acceleration of the rocket can exceed the acceleration due to gravity, so it can move up to the space. So this is the one of the example for Newton's third law of motion. Also, we have a balloon, so blow it completely and then leave it. What happens is the ejection of all the air pushes the surrounding air in the backward direction, so that the balloon can move easily in the forward direction. So likewise it happens. And also, so when you are taking a book is placed on the table. So there all the objects on the earth, it experiences a force due to gravity. So that means this body is also experiencing a forces due to gravity. So here what happens is, initially is having a force, that is forces due to gravity, for force from the gravity, so it experiencing here. But here this table, for example, consider it as a table. This table applies an equal amount of forces and in opposite direction of acceleration force due to gravity. So that's why, so it remains constant here. So there are one processes there here. So when you are placing a book on a table, so initially it experiences a forces due to gravity. There is one force applied on this object, but here this table cancels that forces due to gravity, or cancels that forces due to gravity applied on this book here. So that's why here action and reaction takes place here. And while you are walking, so you are moving in the forward direction because of frictional force. So that one is a contact force here. So there in any forces, so whatever the forces it is applying means there are at least two forces are there, at least two objects are there. So both the objects are interacting with the forces. Those two forces are equal in magnitude and opposite in direction here. So this is the Newton's third law of motion here. So there are many examples are there. You can take many all the examples it is. So here it is the principles of those two examples, which are the examples of Newton's third law of motion. So based on these examples, so this is naturally existed. Those two are naturally existed. So and all the other also naturally existed. But when you are taking the launching of rocket, so those are the applications we can take. So this is about Newton's third law of motion here. So let us move on to the next topic, that is conservation of momentum. So this is also related with the Newton's third law of motion. Identities. So Here just observe there are two terms are there, that is conservation of momentum, conservation and momentum. Conservation means, so momentum we already know that one, that is the product of mass and velocity. So that one, that things depends on the mass of an object and which velocity it is moving. So like that we have to take, that is product of mass and velocity depends on mass of the body and velocity of the body here. Yes, then conservation. Conservation means constant. For example, it is a relating word, that is constant. Conservation means whatever the quantity, so you can take conservation of velocity, conservation of energy, or conservation of mass, like that. You can take whatever that conservation means. The conservation nothing but that quantity neither be created and nor be destroyed. Neither be created and nor be destroyed. It can changes into one form to another form. One form to another form it can take, or passes from one body to another body. So like that it happens. So that means the total, when we are taken the total of that quantity, it must be always same, like that. So here there is a chalk piece is there. That means here it's a complete chalk piece. The mass is something, so the weight of the chalk piece is something. So when I am just pieces into two parts, when you are weighing those two together, so the mass is also same here. So that means that one is the constant, that is conservation of moment. Before pieces, so here it is the same, the mass is same. We are before applying the forces, the mass is same as after applying the forces. Before applying the forces and after applying the forces, the masses of this object is same. So that one we are call it as a conservation. That means the mass neither be created nor be destroyed. So it can changes from one form to another form, or changes from object to object, like that. So here it is also conservation of momentum takes place. That means here momentum based on only one object. So whether it is two objects are there, no. In case of collision we can take, that is the new term, it is collision. Collision means the interaction between two objects, we are call it as a collision. When the accident takes place, when the accident between two bikes, two cars, at that time, what happens is before applying the forces, some momentum is there. That means in both the objects there are some momentum are there. And after the collision also, collision means in that time both the forces are applying the some amount of forces. Their interaction takes place. Newton's third law happening there. That means one action and reaction process are going on. There what happens is the forces are equal in magnitude and opposite in direction. And after the application of force, the first body moves with the different velocity. Second body also moves with the different velocity. Even if in the case the total momentum also same. Before the collision also same, and after the collision. Before the accident also the total momentum between those two bodies is same, and after the collision also, after the accident also, the momentum between those two objects or those two vehicles are same. So let us consider the statement. Mostly we have to take the statement, that is the total momentum before collision is equal to total momentum after collision here. So that means here momentum is neither created nor be destroyed, like that. That is total momentum before collision is equal to total momentum after collision. Yes. So here I am taking only two objects here. For example, here I will take two objects, that is one is A, another one is B. It is A and it is B, and this is having a mass m1 and this is having a mass m2. So here it is moving with some velocity. So let's take some, it moves with some velocity u1, and this is also moves with some velocity u2. So here I am considering two objects, that is A and B, of mass m1 and m2 respectively, moves with the velocity u1 and u2 respectively. So let us take that one. Consider two objects. Consider two objects A and B of mass m1 and m2 respectively, and moves with the velocity u1 and u2 respectively. Moves with the velocity u1 and u2 respectively. So here it is a case, two bodies are there of mass m1 and m2, moves with the velocity u1 and u2. And after some interval of time, after some extent of time, so both the objects are collide. So that means here it is a collision takes place. That means here what happens is both the objects are collided. Here it is, both the objects are, it's A and it's B, having mass m1 and it is mass m2. So both the objects are collided here. Here it is, we can the first body experiences forces to the second body, that is B body. That means it is FAB. That is, here it is, we can take it as FAB is applying in this direction, and here it is FBA. Here it is in this direction. Here it is in this direction it applies, and here it is in this direction. So when you are interchanging that arrow mark, that means you have to insert a minus sign there. So when you are writing in the formula, so you have to take the minus sign there. So here, firstly consider in this case the momentum of first object. What is the momentum of that one? PA. So PA is equal to, you can take m1 u1, and P2 you can take, P2 is equal to m2 u2. What is the total momentum here? u1 PA plus PB. Here I will take this a PB. PA, so total momentum P is equal to, before collision I will take P1. PA plus PB is equal to m1 u1 plus m2 u2. So this is, take this as equation number 1. That means here P1 is the total momentum before collision. That is, P1 is total momentum before collision. Total momentum before collision. Yes. So here the first case, the two bodies are moving with a different velocity. Here it is collision takes place. After collision, two bodies are moving with different velocity. That is, here the body m1, so A body, that is mass m1, and here it is second body mass m2. It moves with velocity v1 and it moves with velocity v2. So that is, after collision, the body A moves with velocity v1 and body B moves with the velocity v2 here. That is, after collision, the object A moves with velocity v1, and body or object B moves with velocity v2. Moves with velocity v2 here. So here I am taking another part here. So before that, I think you know that one. So after that you have to write here. So here I am writing this diagram part. Yes. So that means here what happens is after collision the PA and PB changes. That is, I will take it as a PA dash. PA dash means after collision the momentum of object A, that is m1 v1, that is mass into velocity. Here it is also mass into velocity, here it is also mass into velocity, here is also mass into velocity, but mass doesn't changes, but the velocity changes here. That is, another it is PB dash. PB dash is equal to m2 v2. What is the total momentum here? That is P2. I will take it as P2 here. That is PA dash plus PB dash is equal to m1 v1 plus m2 v2. So I will take this as equation number 2. Yes. So we have the total momentum before collision and total momentum after collision. That is P2 is the total momentum after collision. Then we have conservation of momentum, that is total momentum before collision is equal to total momentum after collision, that is according to conservation of momentum. According to conservation of momentum, you can take P1 is equal to P2, that is m1 u1 is equal to m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Yes. So here we have the formula to represent. Formula is representing the conservation of momentum. Here you can take MAUA also. MAUA, MBUB is equal to MAVA plus MPVB. Likewise also you can take, here I am taking M1U1 plus M2U2 is equal to M1V1 plus M2V2. So it is very easy to pronounce also. So this is the conservation of momentum. Here in this chapter, here in this video, we are discussed about Newton's third law of motion and conservation of momentum. So both are interrelated. So it is also based on Newton's second law of motion also, because the momentum terms came here. So that's why. So Newton's third law of motion is also there, that is the interaction between those two objects takes place. That is that FAB is equal to minus FBA. So you can take that, but here the derivation part is deleted or removed from the syllabus. That's why here this idea, this elementary idea is enough to you in this year. So I hope you enjoyed this and also you understood that one. So those who are watching this video for the first time, please subscribe our channel and don't forget to press the bell icon. Also hit the like button. So thank you one and all. Be safe and stay home. Thank you.